Welcome back. In this video, we are going to talk about another one of the important concept of data structure. Let's understand this new concept with the help of an example. Let's say you own a grocery store where different types of fruits and vegetables are there to sell. So whenever a customer comes and he buys some fruits and vegetables, so what owner did, he will take some time to find out the price of that exact product. Let's say he buys an orange and orange price is 60 rupees, but whenever a customer comes to buy that orange, so he will take some time to find out how much prices of that product. So that will take some tedious time. So to solve this problem, what owner did, he tried different approach. The first what he tried a linear approach. Okay, now how did he establish the linear approach? Let's say there are three fruits are there. Fruits are like orange, which is the cost of rupees 60, mangoes, let's say it is rupees 120 per kg, and another one is bread. Let's say rupees 55 per packet. Okay, so here we can see that orange, mangoes and breads are presented in an unsorted list. From that, what he did, we approached, or we can say that owner approached linear search. We have already know the complexity of linear search, that is order of n, and the graphical representation of linear search will be order of n. This will be the graphical representation, but the process is still taking too much time. We need more faster process. So this time he tried another approach. For that, what we need to do, we need to sort this fruits and vegetables. So he sorted. After sorting, it will arrange it in this manner. And the complexity, and through that we approached the binary search, and the complexity of binary search will be order of log n, and the graphical representation, it will look like this. Order of log n. So we already know that binary search is faster than linear search. Okay, but still it is very painful to owner to look every time the price of a product while customer waits. So what can owner did, he can hire an assistant who will remember the price of every product so that customer does not have to wait. In that case, complexity, it will be something like, you can say, constant time. Let's say order of one time it will take. Yeah, that is the constant time, right? Order of one time it will take, so that no matter how many products are there in that grocery store, customer doesn't have to wait. Now let's think the same. Another one is list, correct? But in that case, we have to remember the items. But in this case, we have to remember the items, and the complexity of finding that item should be in around order of one time. That's where has function comes in. A hash function is a function where you put in a string, and you get back a number. Let's say I have put orange, and I will get back a number, that is 60. Same thing when I will put mango, I will get a number 120. Bread 55. Basically what we are doing is mapping string to a number. The hash function tells you exactly where the price is stored, so you don't have to search at all. Put a hash function and an array together, you get a data structure called hash table. A hash table is the first data structure you will learn that has some extra logic behind it. Arrays and lists are mapped straight to memory, but hash tables are smarter. They use a hash function to figure out where to store element. They are also known as hash maps. Dictionaries and associative arrays. The thing is, we never have to implement hash table ourselves. Any good programming language will have an implementation of hash tables. Java also has an implementation of hash table. So what we will do, let's see how we are going to use hash tables in Java. So what we are going to do, first of all, we are going to include that hash table class here. So I told you I will take this time a string and a number. And I'm going to name the reference will be hash table. Yeah, the reference name will be hash table. Okay, I have reference number. Now I'm going to store two different types of fruits and vegetables. First of all, I'm going to store here alright. Now, so have we stored our data in a hash table. Let's print all those values first. Okay, so for that we are going to use for each loop. Data dot get value. Let's run. Now you can see that all the three values printed it here, correct? Now what if I wanted to see the price of a particular product? For example, let's say I just wanted to see how much price of orange is that. Then how am I going to see? So what am I going to do? I'm going to write has table dot get, and here I'm going to name the string. String is orange. Now let's execute. And here it will return the price, and that is 60. Same thing I can do with bread also. It will return 55. Now what if I wanted to remove a hash table? I wanted to delete. For that, what am I going to do? I am going to write here hash table dot remove, and here the value that will be bread. Let's save it. Now you can see that after deleting, if I am printing it out here, it is returning null. So what if I do not want it to return null? So what am I going to do? I am going to do something right here. I am going to use hash table get one minute. I'm going to use get or default. If bread exists, then return the correct value, that is 55, otherwise return 0. So here I am deleting bread for now. So if I'm going to execute, here I can see that it is showing 0 instead of null. Now if I will make it comment in this one, and then if I again execute, here it is showing the 55 value. Okay, so there are many other things also there in hash table that we can implement. Let's see one by one all those different types of methods. Clone is there, contains to check the value, contains key, contains value, equals, has code, is empty, remove, replace, size, toString, and many more elements. Entry set, we have seen the use of entry set. Get, that also we have seen the use. Get a default, that also we have seen the use. There are many more values are there which we can use and test. Okay, but in this one I have covered 3 or 4 points. If you want, you can play around with this hash table, and through that you will learn many different things. Okay, different uses of hash table implementation. So up to now we saw the implementation of hash table. Now let's see the implementation of hash table in a cache. Let's again take an example. I'm good with taking an example. I think it will be better. Yeah, I can teach better if I will take it as an example. So that's why maybe I'm taking all the time as an example only. Let's take an example here to understand about cache. Let's say you are a user and you are searching for a cooking website for a particular recipe. So what you did, you make a request to a website server. Okay, server provides you the recipe with the help of a web page. To providing this data to you, server will take time. Okay, whenever user will ask to a server will go to the server will look for this web page. For that, all the procedure, server will take time. So when you will look for same page in some other day, so instead of server looking for again, what it will do, it will memorize it when you have looked for the first time, and it will send back to you that web page that you have seen for the first time. So what it will do, it will memorize it and it will store it. So again you will look for it. So instead of searching for that one, it will look into that place where he has stored that all those things which you have earlier searched, and through that he will directly grab that web page. Okay, it is already stored there, so he's asking for the same thing, so let's grab it from there and give it back to the user. So this whole process, this is called caching. It has two advantages. You get a web page a lot faster, and another one is okay, caching is a common way to make things faster, and the data is cached in hash. Flowchart of the code will somewhat look like this. Here we are going to check, is the URL stored in hash? Okay, if the URL is stored in hash, is the URL stored in hash? Yes. Then in that case, If it is yes, then send the data in the cache. Okay. Okay. If the answer is no, then ask for the server for a web page. Ask for a server in web page, and also store the data in hash. Okay, and that is the designing of the what it will the code look like. Okay, for the so I'm going to show you the basic pseudo code so that it will grasp the scenario how it is working internally. It will somewhat it will look like this: get request, URL. Okay, if URL exists in the cache, if it is true, in that case return cache so that it will take less time. Okay, it will take less time instead of finding server to a web page. Else, if it's not there, in that case what we can do is, first of all we are going to access the data from the server. Okay, and after accessing the data from server, we are going to store that data in cache, and after that, last but not least, we will return the data to a user. So this is what the pseudo code will look like. So to summarize the complete statement of the video, you will understand there are 2 or 3 things that we covered. We covered the relationship between key pair and value pair, key and value, and the benefits of hash tables are it will not occupy duplicates, so it will be easier for us to finding out the duplicate values. And third one is the caching data instead of making your servers do work will save plenty of time. So with that, this is the end of the video, and again in the next video we are going to cover another one of the important concept of data structure. So stay tuned and keep watching Adhyan channel. Thank you.